All right, guys, so this is the first practice problem on our kinematics math practice. We're going to be using a couple of different new equations. We're going to dive into some older equations, but as you can see with this very first one, I've gone ahead and I've highlighted all the values that the question gives me, and I recommend that you guys do this too, either highlight them or underline them, and then I've begun to write out the information again that it gives me. So we have Science Steve. He's driving his car with a speed of 2 meters per second to the north. After 5 seconds, he's traveling 12 meters per second north. Okay, so we know that we're staying in the same direction. Okay, so I can kind of leave my signs as they are. We want to know what is Science Steve's acceleration, and then we want to know how far does Science Steve travel during this time. Okay, so I've written out all the details I have. I've got my initial velocity, final velocity, as well as the time that's gone by. Now, in order to find acceleration, okay, we are looking for A for acceleration. We have a couple of different kinematic equations that we can pull from, but I recommend sticking with our bare bones acceleration formula, right? Recall that acceleration is your change in velocity over time. We have the velocities, so we can figure out the acceleration based on how much time has transpired. Okay? So just going to fill in what I know. The acceleration, that's equal to the final velocity minus the initial, so 12 meters per second minus 2 meters per second. Okay? And all of this is put over the amount of time that's gone by, which is 5 seconds. Okay, so 12 minus 2 is 10 meters per second, all over 5 seconds. Again, simplify that a little bit further. 10 divided by 5 is 2, and then because this is acceleration, our units are going to be in meters per second per second. So this means every single second, Steve is increasing his velocity by 2 meters per second. Okay, so that's all well and good. Now we want to figure out how far does Science Steve travel during this time. Okay, so if we're looking at how far, right, this means that we are looking at a change in position. Okay, so what we have to do is we have to refer to all of our available kinematics equations. And I'm just going to focus on the 4 that we talked about. And we need to find the equation that contains the details that we know. Okay, and also allows us to find our unknown. Okay, now before I dive into these equations, I actually want to take this acceleration that I found. I'm going to put it in with my known values, okay, because I want to add this to my toolbox in case I can use it later. Okay, so now instead of 3 variables, we can actually work with 4, right? Okay, so sometimes it's easier to review the equations that don't work and just eliminate them from the ones that we can try. Okay, so we're looking for a change in position. Okay, so right off the bat, doesn't look like we're going to need this equation because it doesn't tell us anything about change in position. So that's all but useless. We've got a potential here, right? We can find change in position. We have the initial velocity, we have the time, we have the acceleration. Okay, so this is a contender. We could also use this one, right? We again have initial and final and time, so we could use this equation if we have to. Or we could use this one, okay? Same little job, right? We can have the final velocity, the initial velocity, we have the acceleration. The only thing we're missing is our change in position. Okay, so any of these 3 will work. Now it's just kind of up to you to figure out which one do you want to work with, okay? Now I like the simplicity of this one, because for one, it's already set equal to our changing position, so that's helpful. And there isn't a whole lot of squaring values and adding halves and things, so let's stick with a simple option. Okay, so using the following equation, we can solve for our change in position. So change in position is equal to 1/2 times the initial velocity plus the final velocity. So initial was 2 meters per second. The final was 12 meters per second. Okay, and then we're going to multiply that by our change in time, which was 5 seconds. Okay, so now it's just a matter of order of operations and simplifying what we can. All right, so let's start with these parentheses. That's 1/2 times 14 meters per second, and then multiply that by 5 seconds, and then we can just go straight across. Okay, so 1/2 times 14 is 7. And then 7 times 5 is 35. 35. Okay, so there is our change in position. And because it's change in position, we're going to have our 35 with the meters unit. Okay, so hopefully that was a helpful walkthrough for the first one, and then we'll do the second one next.